Hey y'all, it's Mr. Boyden back at it again today, and we're talking today about rhombuses and rectangles. And we've spent some time in the previous lesson talking about parallelograms. Both rhombuses and rectangles are parallelograms, but they're special cases. The rhombus being where all four sides are congruent, we can see an example here, and the rectangle being where we have four right angles. So let's get into it. We're going to talk about some facts that we have, some examples, and we're going to see how those are often used to challenge you. Okay, so 6-9, that's just a reference to the textbook that we have. Each diagonal of a rhombus, something, the two angles of the rhombus. So let's take a look at this picture down here and see if that helps us understand what that's talking about. Okay, so I've drawn in one diagonal here, P to Q, and what we want to know is what that does to angle Q and to angle P. And so that breaks it up into two sides. I'm going to call that 1 and 2. And so based on what you see, do you think those angles are the same or do you think they're different? It should be pretty clear that those angles are the same. 1, 2, in fact, 3 and 4, I'll make that actually look like a 3. 3 and 4 are the same as well. And if you're not sure why, take a look at this. Notice PQ in the middle. That is a side length that's in both the upper and the lower triangle. And so because of the reflexive property, we can mark it in that fashion. And then by side congruence, notice 1, 2, 3 sides are marked. 1, 2, 3 are marked. By side congruence, we can see that these two triangles are congruent. And then angle 1 and angle 3 are congruent. Why? Because this is an isosceles triangle, and those are the base angles. So that then tells us that 1, 2, 3, and 4 all have to be congruent angles. So what word am I going to use here? Well, the technical word is bisects. It bisects the two angles, P and Q, and so we end up with 4 congruent angles. Okay, that's going to be our first part. Now, the second thing we need to talk about is what if I had both diagonals drawn in, like in this picture? What are the measurements of the angles made by the diagonals? So what I'm asking about is this right here. And one way I'd like you to think about that is let's take a look at this picture and ask ourselves, first of all, how many triangles are there? Okay, well, you could make an argument that there's quite a lot. I'm going to focus on these 4. So 1, 2, 3, and 4. Like it looks like 4 triangles were put together to make the shape. Okay, and do you think those triangles are the same or do you think they're different? Okay, well, based on the fact that we already know every rhombus is a parallelogram, that indicates to us that since the diagonal was bisected, those two segments are congruent, and the other diagonal is bisected, which means that those segments are congruent. So by side congruence, every single triangle in this image is congruent. And that's going to make this a lot easier to answer this question. What are the measurements of the angles formed by the diagonals? Well, check it out. There's 4 angles in the middle. 1, 2, 3, and 4. And if there's 4 angles, and we know they're all congruent, well, just notice I'll draw in the segment markers, all congruent. And I'll draw those in. And look, my handwriting's poor, but that's a circle. And we know a circle has 360 degrees. And if there's 4 angles that have to share that, let's divide by 4, so we're sharing evenly. That's 90 degrees. So what are the measurements of the angles made by the diagonals? 90 degrees. Or you could say that the diagonals are perpendicular. Now, to be really clear, do you know what kind of shape we're talking about? Because this does not apply to all parallelograms. It specifically applies when the 4 sides are equal or when they're congruent. So this is a rhombus. What we're talking about only applies to rhombi. That's the plural form, is rhombi. Singular rhombus, plural form rhombi. Let's look at 2 examples. Okay, here's our first one. We're going to be asked to find the angle measures of this rhombus. So first things first. Remember, if it's a rhombus, we have 4 congruent triangles. So if you've got a 78 right there, you've also got a 78 right there, and a 78 right there, and those are degrees, and angle 1 is also 78. Okay, that was fact 1. That was one of the first things we talked about. It's going to bisect the angles. So look, the 2 sides are the same, the 2 sides are the same. Also, we just found out that the diagonals are always perpendicular, and so angle 2 is a right angle. I'm going to make a mark there that that's 90 degrees, which means that that's 90 degrees, and that's 90 degrees, and that's also 90 degrees. They're all 90 degrees. And then to find angle 3, remember, this is a single triangle, and a triangle always, if we add up the interior angles, or at least always in a plane, it's going to add up to 180. So what we have then is 180 degrees minus 78. We got our 90 degree angle there, so minus 90. And that sums, or excuse me, when I subtract that from 180, I get 12 degrees. So angle 3 is 12 degrees. And that's done, y'all. That's all it is. Now I'm going to put another example up here. I want you to pause the video, and then you're going to Try the question on your own. Play it to see how you did. Okay, here's the second question. Okay, so I'm told it's a rhombus. Boom, automatically I know that angle 1 is 90. If that's 50, remember this is an isosceles triangle here. And so if that's 50, this is also 50. We learned that the diagonal always bisects the angle, so 2 equal halves, so that's 50. And I got to be a little bit careful. A lot of people want to just put a 50 right there. That would be really easy, but it's not true. So we know the diagonals make 90. You got 50 there, 90 there, and something there. So let's do 180 minus 50 minus 90, and we get 40 when we do that. So this is actually, I'll just fill it in like that. That's actually a 40-degree angle. Okay, and that's all done. Now let's have some discussion about rectangles. So we're going to try to get out some facts about rectangles. You could call them theorems. Rather than me just reciting theorems to you, I think I want to teach this as asking you some questions about what you see and seeing what makes sense based on that. So the first question I want to ask you is, which diagonal is longer? And I'll draw the first one in red, and I'll draw the second one in black. And the question is, which one is longer, the one in red or the one in black? Okay, so I hope that you can see that these are the same. Okay, they are congruent. So that's going to be the first thing we're going to write down here. We're going to write down that the diagonals of a rectangle are congruent. So facts. So number 1, diagonals are congruent. Okay, that's number 1. We're going to have a second fact in here in just a second, so I'm going to number it now. Next thing I want you to notice is on this picture, what is greater, or what is a greater length? Is it the left side of this diagonal, or is it the, I guess I call it the right side? So the segment in blue or the segment in green? What's longer? Now what I hope you're shouting at your screen right now is, hey, this is a parallelogram, and we already learned that in every parallelogram, the diagonals bisect one another. So those two segments are congruent, and these two segments are congruent. So I'm going to add that over here now, that the diagonals bisect. Okay. Now, one of the things that's really confusing about this particular unit of study is a lot of people accidentally apply theorems that are not true to the wrong shape. So for example, a lot of people are going to look at this and they're going to wonder about this angle right here. And I'm wondering, can you tell how many degrees are in that angle? Is it obvious to you? It's not obvious to me. And in fact, I actually don't know what it is. So I'm going to make a little note here for myself. If I have a rectangle, I'm going to say that's not necessarily 90. It could be, but then it'd be a square. So I'm going to say not necessarily 90 degrees, because it might be, but we don't know that. The other thing I'd want you to notice here is, as opposed to the rhombus where we had 4 congruent triangles, call this 1, 2, 3, 4 different triangles. Are all these triangles the same or not? I hope you can see they're not all the same. There is a pair of congruent triangles. Triangle 1 and 3 are congruent, and triangle 2 and 4 are congruent, but 3 is not congruent to 4. So you'll want to keep that in mind when you're solving questions involving rectangles. Let's try this typical example problem involving rectangles. One diagonal of a rectangle has a length 8x plus 2. The other diagonal has length 5x plus 11. Find the length of each diagonal. All right, y'all. One strategy for this is to draw a picture. I'm actually going to skip that today, and I'm going to do things the quick way. Because, first of all, I'm going to identify what's the question about. It's about diagonals. I have one diagonal, and I have another diagonal. If I can remember the relationship between the diagonals of a rectangle, then I'm going to be successful here. So I'm going to rewind for a minute. We wrote down a minute ago that the diagonals are congruent. And congruent means they're the same, or that they're equal. So that tells me I'm going to take one diagonal, 8x plus 2, and I'm going to take the other diagonal, 5x plus 11, and I'm just going to make an equation that says they're the same, that they're congruent, or that they're equal. And so now that I have that, I'm just going to go solve it. So let's do some algebra steps. You may wish to pause the video and try this on your own. In fact, I would encourage it so you can build up your confidence and get some feedback. But here I go. I'm going to go minus 5x on both sides. And I'm going to go minus 2 on both sides. And then I get 3x equals 9. And then x is going to be equal to 3. Double check, did we answer the question that was asked? We did not. And so I need to go back and plug those in. They asked how long the diagonals are. They didn't ask what x is. So I'm just going to go like this. Instead of 5x, I'm going to put 5 times 3 plus 11. Okay, and that turns out to be 15 plus 11, which is 26. Awesome. I'm going to do the same thing over here. 8 times 3 plus 2, that's 24, plus 2, which is 26. And look at that. We got the same thing for each. That's a good sign. That actually tells me that we got this right. Our x value is correct. Because if those weren't equal, that would violate what we said right here. We said, hey, they should be equal. The fact that they're equal means our algebra steps are good. So guys, that's all for today. Hope you enjoyed the practice, and I hope the video is helpful, and I'll see you next time.